All right, Mr. Arnold here with Aaron again. We're going to take a look at periodic table of elements. This is really chapter 16, section 1, making sure we have an idea of what's going on the periodic table of elements. We just want you guys to be able to basically read what's happening. We talked a little bit about the element squares in 16.2 and understanding that on the element squares we have a whole number. That whole number is related to the atomic number, which we should know by now is the number of protons and also equal to the number of electrons in the atom. We also have a decimal number. The decimal number is the average atomic mass, and the average atomic mass takes into account for all of the isotopes that might be available for that element. So we just round the atomic mass number up or down based on our rounding rules to get the number of neutrons, and we get the number of neutrons by simply taking atomic mass minus atomic number, and there's our atomic or our number of neutrons. With the periodic table, you'll notice there are a couple things that you will see. You will see groups that are running from top to bottom. Those groups are what we call families, and anybody inside of those families have similar characteristics. So we're going to take a look at the alkali metals here. On the far left, starts with lithium, then it goes down to sodium, potassium, rubidium, cesium, and francium. Those are all highly reactive with water. Actually, it's pretty cool. Throw them in water, and if you have a big enough chunk, they actually explode in water. So those are pretty cool little elements to mess with. And then the next group over are our alkaline earth metals, and they have a completely different set of properties. Even though they're right next to each other on the periodic table, a completely different set of properties. So families are the ones that run from top to bottom. We also call those groups, so sometimes you'll see the alkali earth metal group or the alkali metal group, etc. from there. You have this big chunk in the middle. This big chunk in the middle are called transition metals. The transition metals play by a different set of rules, and so we will talk a little bit more about those when we get into bonding, but they don't necessarily behave like all of the other families and groups. One of the other things that you will notice is this group right here. As we go down and make this little staircase step, any one of these elements that we are kind of covering in brown are considered metalloids. Metalloids is the staircase step that goes down, excluding aluminum, that actually separates our metals from the other side of the table, which are our nonmetals. Most of the elements to the left of the metalloids are going to be called metals, and the elements to the right are going to be simply called our nonmetals. Now, just because they're metal or non-metal doesn't mean that it's gas or solids or liquids. It depends. There's only a few that are actually solid or liquid at room temperature. Mercury, which is a metal, and bromine, which is a non-metal. And there are only a handful that are gas as a room temperature, and those are mostly our noble gases, with hydrogen, which is over here on the far left. So, taking a look, another group that I want to point out is this far right group. These guys are the noble gases. These guys are actually the only elements that are absolutely stable. Okay? Our noble gases are actually stable. They don't like to bond with anything. They don't like to necessarily interact with all the other ones. The other thing that we haven't pointed out, and I'm going to change colors here for a second. Hopefully I can get a better color. Let's see. So one of the other things we haven't pointed out is we have these groups, or I'm sorry, not groups, these rows that are running across. Rows that run across are called periods. They have very similar atomic structure. We are just adding one proton to the atomic number as we move from left to right. If we add one proton, we also add one electron. So as we look at them structurally, they're about the same, even though they actually behave very different. Potassium, very reactive in water, likes to catch on fire, likes to blow up when you drop it in water. Calcium, very non-reactive at all in water. So it doesn't even really react. We can put it in water and it'll just slowly, there you go, Mikey. it'll slowly start to dissolve inside of there. But this is modern periodic table. Again, it's based off of the atomic numbers. So as we move from left to right and we move from top to bottom, we increase in the atomic number. We have some families which are going up and down, the vertical columns. And then we have some rows that go across as well. Just some things that you need to be aware of and kind of think about as you're looking at the periodic. A couple other things that I kind of forgot to mention now that I take a look. Metals, some properties of metals. Metals are mostly solid at room temperature. They're found on the left-hand side of the periodic table. The other thing with metals are they typically are very conductive of heat and of electrical energy, meaning they pass electrical energy pretty quickly. As you guys know, copper we use in wiring in the houses, copper pans, things like that for cooking. Non-metals are not very conductive. They do not pass heat or electrical energy very well. In fact, we use those as insulators when we are trying to build something to keep that from actually going. The stair-step case here in the middle, and I'm just going to kind of touch all of these guys, are metalloids. Metalloids are actually elements that have properties of both metals and non-metals. So some of them can be conductive, some of them may not be conductive, some of them may be very good insulators. It just depends, but they have a little bit of the properties of both metals and non-metals at the same time. Other than that, that's pretty much everything you need to know. Most of the elements come from one big thing, and that big thing is called a star, because as a star fuses and creates light energy, it takes hydrogen and turns it into helium, helium into carbon, and carbon then can be turned into a bunch of different other things. And actually, when stars go boom boom or explode, most of you guys are used to hearing about a supernova. That supernova explosion actually creates all of our heavy elements. So those really, really heavy elements like nickel and cobalt and lead and those things are actually created inside the explosion of a star, which is actually pretty cool. So I think I got it all. I'm going to try to save this now. Hopefully the volume is on. That would really not be good. And if you got any questions, as always, come talk to me.